Hello students, welcome to online maths classroom. Today we are going to take up tangents and normals exercise 6.3 of your application of derivatives. So let us start with it. Question number 1 is find the slope of tangent to the curve at x is equal to 4. Okay, so given equation of curve given here is y is equal to 3x raised to power 4 minus 4x. Now slope of the tangent to the curve is the value of the derivative at that particular point. Okay, so we will find first derivative dy by dx. It becomes as like 4, 3 is 12, x cube minus 4. Okay, now slope of tangent at the point x equal to 4. Okay, the point here is x equal to 4. So what I will do is I will check this derivative dy by dx at x equal to 4. Means put x is equal to 4 here and you will get it as 764. Number 2 is find the slope of tangent to the curve at x equal to 10. Similarly, you have to, this is the function. Okay, I have to find dy by dx using quotient rule. So this is my derivative. Minus 1 upon x minus 2 whole square. Now the value of the derivative at this point x is equal to 10. The value of the derivative at x is equal to 10 will give me the slope of tangent to the curve at this point. So that means I'll put minus 1 upon 10 minus 2 whole square, that is 8 square, that is minus 1 upon 64. Number 3 is find slope of tangent to the curve at the point whose x coordinate is 2. Okay, so if you require y coordinate, you can get it by putting 2 here. Okay, otherwise simply by putting the value of x you will get the, and it is again the value of derivative, that is slope of tangent to the curve is the value of the derivative at point x equal to 2. So this is the equation, this is the derivative, and slope of tangent at x equal to 2 is given by, so only x value is there, so it is 3 into 2 2s are 4, 3 4s are 12 minus 1, that is 11. Now 4 is find the slope of tangent to the curve at the point whose x coordinate is 3. So simply y is this is derivative, and slope of tangent is your dy by dx at x equal to 3, that is 24. Number 5 is find the slope of normal to the curve. X is equal to a cos cube theta, y equal to a sin cube theta at theta equal to pi by 4. So I know it is a parametric form. So I'll first find dx upon d theta, then I'll find dy upon d theta, and then I'll find dy by dx by dividing dy by d theta by dx upon d theta. So it becomes your, like this derivative of x is dx upon d theta is your, like it is 3a square, 3a cos square theta, and then derivative of cos theta is minus sin theta, right? And similarly the other part can be like this. So dx upon d theta is minus 3a cos square theta sin theta, and dy by d theta will be your 3a sin square theta, and derivative of sin theta is cos theta. So dy by dx is minus sin theta upon cos theta, that is minus tan theta. Now slope of tangent at theta by 4 will be the value of the derivative at theta by theta equal to pi by 4. So I get it as minus tan pi by 4, that is minus 1. So this is the slope of tangent, and slope of normal is negative reciprocal of slope of tangent. That is, if slope of tangent is m, then slope of normal is minus times 1 upon m, right? So I'll simply find that it is your minus upon minus 1, that is 1. Okay, so slope of normal is your 1. Number 6 is find slope of normal. Again, it's a parametric form, x equal to this, y equal to this, at theta equal to pi by 2. So I'll first find dx upon d theta, then I'll find dy by d theta, and then dy by dx turn out here as 2b upon a sin theta. Now slope of tangent at theta equal to pi by 2 is the value of this derivative, that is due 2b upon a, and sin 90 is your 1. So it is 2b upon a, and the slope of normal will be negative reciprocal of this, that is minus 1 upon 2b upon a, that is minus a upon 2b. Number 7 is find the points at which the tangent to the curve is parallel to x-axis. Okay, so this is the curve. Okay, dy by dx, that is 3x square minus 6x minus 9, and it is equal to the slope of tangent at point xy. Now since tangent is parallel to x-axis, okay, so I know the slope of x-axis is 0, and any line parallel to if two lines are parallel, then their slopes are equal. So that means here since tangent is parallel to x-axis, that means this dy by dx equal to 0. So from here I'll get a quadratic equation, and on factorization I'll get x as 3 and minus 1, and the y value can be calculated from here. So when x is 3, y is minus 20, and when x is minus 1, y is your 12. So I get the points 3 minus 20 and minus 1. Number 8 is find a point on the curve y equal to x minus 2 whole square at which the tangent is parallel to chord joining the points. Okay, so again, this first of all I'll just find the slope of chord. So slope of chord can be calculated by using y2 minus y1 upon x2 minus x1. That turns out to be 2. Now equation of curve is this, and slope of tangent at xy will be your value of derivative at this point xy. So it becomes 2 times x minus 2. Okay, that is 2x minus 4. And now since this tangent is parallel to this chord, so that means their slopes are equal. That means 2 times x minus 2 is equal to this 2. From here I'll get the value of x, that is 3, and y can be calculated by resubstituting the value of x here. So I get y as 1. So that is the point is 3, 1. Number 9 is find the point on the curve at which the tangent is y equal to x minus 11. So again the equation of curve is this and tangent is this. So I can reset it in the form x minus y minus 11 equal to 0. Now the value of derivative is 3x square minus 11. Now slope of tangent at xy is again 3x square minus 11. But slope of tangent from this equation here is turning out to be 1. You can also check it by comparing it like y equal to mx plus c. So m is here 1. So since this tangent is same, okay, point on the curve at which this is the equation of tangent, so that means slope of tangent is same as this one. So I get 3x square minus 11 equal to 1, which gives me x plus minus 2. And when x is 2, I'll calculate y from my equation, that y turns out to be minus 9, and when x is minus 2, it turns out to be 19. So the points are 2 minus 9 and minus 2, 19. Okay, but we can check that this minus 2, 19 is not satisfying my equation number 2. Okay, so that means the required answer is 2 and minus 9. Number 10 is find the equation of all lines having slope minus 1 and are tangent to the curve y equal to 1 upon x minus 1 for x not equal to 1. Now again equation of curve is this. So you can write it this to avoid quotient rule. So it's like x minus 1 raised to power minus 1. So the value of derivative is minus 1. You know the derivative of x raised to power minus 1 is like minus 1 upon x square. Okay, so it becomes like this. Now slope of tangent to the given curve at point xy is this. Okay, this is minus 1 upon the value of the derivative at point xy. So it is minus 1 upon x minus 1 whole square. But the slope here is given as minus 1. So that means this value is equal to minus 1. So on equating, I'll get x value x as 2. Okay, as I have to open the square, so I'll get two values. One is 2 and one is 0. So when x is 2, my y turns out to be 1. So the point of contact is 2, 1. And in this case, the equation of tangent by using y minus y1 equal to m times x minus x1 will be y minus 1 equal to m is minus 1, x minus 2. So it is x plus y minus 3 equal to 0. And when x is 0, my y is minus 1. So again for 0 minus 1, I'll get the value using y minus y1 equal to m times x minus x1. That is x plus y plus 1 equal to 0. So these are the required equations of tangents. Number 11 is find the equation of all lines having slope 2 which are tangents to the curve. Okay. Now equation of curve is this. Again, if you want to avoid the quotient rule, you can go like this. So dy by dx is minus 1 upon x minus 3 whole square. Remember that ddx of this x minus 3 is also this, but ddx of x is 1. That's why it is not required here. Okay. Now since this slope is equal to 2, okay, from here I'll get the equation, right? And I'll get that the equation which is x minus 3 square whole square is positive, right? The value should be positive. So it turns out to be minus 2. You can see from here that when I'll compare it, it gives me x minus 3 whole square equal to minus half, which is not possible because square of some number cannot be negative. It will involve the iota term. So hence for this curve there is no tangent which is having slope 2. Number 12 is find the equation of all lines having slope 0 and tangents to the curve. So again start with it. This is my y. The derivative dy by dx is this. Okay. So I can just go for this, like if I want to go for quotient rule, that's okay. Otherwise, again x square minus 2x plus 1 raised to power minus 1 can be used. So this is the slope of tangent at point xy. Now this is given as 0. So equate it with 0. I'll get x as 1. And similarly, accordingly, y is half. So the point is 1 and half, right? And the equation of tangent again can be calculated by using y minus y1 equal to m times x minus x1. So as this is m is 0, so I'll get y equal to half. Okay. Number 13 is find the equation on the curve x square by 9 plus y square upon 16 equal to 1. So this is the equation of Phillips at which the tangents are parallel to x-axis or y-axis. So let's start with it. This is my ellipse. Differentiating, I'll get 2x by 9 plus 2y by 16 dy by dx equal to 0. That means I get dy by dx equal to minus 16x by 9y. Okay. Now, if tangent is parallel to x-axis, I know that slope of this x-axis is 0. So slope of tangent will be 0. So that is minus 16x upon 9y. That turns out to be 0. That gives me my x 0. So when x is 0, I can calculate y from here. It turns out as this term will become 0. So y square by 16 equal to 1. That gives me y square equal to 16. Y is plus minus 4. So my points are 0 plus minus 4. Now if tangent is parallel to y-axis, so you know slope of tangent in this case is not defined. That is infinity. So dy by dx is infinity. That means the reverse of it, dx by dy is 0. Okay. So I'll just check it as instead of minus 16x upon 9y, I check it as 9y upon minus 16x equals 0. In this case, y turns out to be 0. And accordingly, from here, I'll get x square by 9 equal to 1. That is, x is equal to plus minus 3. So the point here is plus minus 3, 0. Number 14 is find the equation of tangent and normal to the given curves at the indicated points. So these are the curves given and you have to check the tangents and normals at 0 and 5. So you are familiar with it that this is the curve, this is the tangent, okay, then the normal is a line which is perpendicular to the tangent. Okay, so equation of curve is this, derivative is this, slope of tangent is at the point 0, 5 is the value of derivative. So I'll find this, instead of this complete equation, put x as 0. So as y value is not there, so you will simply put x as 0. So the answer is minus 10 here. So slope becomes minus 10. So this is the slope of tangent. What is the slope of normal? It is negative reciprocal of it, that is minus upon minus 10, that is 1 upon 10. The equation of tangent at 0, 5 using y minus y1 equal to m times x minus x1. This is your 10x plus y equal to 5. And equation of normal will be y minus y1. Here the only change is in the slope. Slope will be 1 by 10x minus 0. So in this case, the equation becomes x minus 10y plus 50 equal to 0. Similarly, for the second curve, this is the equation of curve. I'll find derivative. Slope of tangent is the value of derivative at the point 1, 3. So I'll put here this 1 and 3. So I'll get here as 2. Slope is 2. So this is the slope of tangent. And slope of normal will be minus 1 upon 2, that is minus half. Equation of tangent at 1, 3 is y minus y1 equal to 2 times x minus x1, that is y equal to 2x plus 1. And equation of normal at 1, 3 is y minus y1 equal to minus half times x minus x1, that is your x plus 2y minus 7 equal to 0. Similarly, for the simple curve y equal to x cube, this is the derivative and which is the slope of tangent also. Okay. Now at point 1, 1, the value will be 3. So this is the slope of tangent. Normal will be minus 1 by 3. And the equation will be at 1, 1, 1 for tangent is y minus 1 equal to 3 times x minus 1. And for normal it is y minus 1 equal to minus 1 by 3 times x minus 1. Okay. So it becomes y equal to 3x minus 2 and it is x plus 3y minus 4 equal to 0. Similarly, for this, the derivative is 2x. Now at point 0, 0, the value of derivative is 0. Okay. So tangent at 0, 0 to the curve will be your y minus 0 equal to 0 times x minus 0, or it is y equal to 0. That is the x-axis itself. See, you can see from the here, like this is a upward parabola. So here the tangent is x-axis itself, and hence normal at this curve is, who is the normal? Here normal is perpendicular to tangent, so y-axis itself the normal. Okay. Now number 5 is equation of curve is x equal to cos t, y equal to sin t. So again parametric form dx by dt, dy by dt and dy by dx we can get by dividing. So it is minus cot t, which is the slope of tangent at the point xy. Now slope of tangent at the point t equal to pi by 4, I can check here by putting minus cot t pi by 4, that is minus 1. Okay. So slope of normal is minus upon minus 1, that is 1. Now t equal to pi by 4, so I can calculate x as cos t y t. Okay, the point is xy, so it is cos t y sin t, that is cos pi by 4 sin pi by 4. So it is 1 by root 2, 1 by root 2. So equation of tangent becomes y minus y1 equal to m times x minus x1. On simplification, I get it as x plus y equal to root 2. And for normal, I'll use the slope of normal, that is 1. So it is y minus y1 equal to m times x minus x1. And in this case, after cancellation, I'll get y equal to x is the required normal, equation of normal. Number 15 is find the equation of tangent line to the curve. This is the curve which is perpendicular to the line 5y minus 15x equal to 13 in the second case and parallel to this line. So again, you know the connection between the parallel and perpendicular lines. The slopes of parallel lines are same and the product of slopes of perpendicular lines is minus 1. So again start with the curve, the derivative, slope of tangent 2x minus 2. The slope of the given line, the first part is you can express it as y equal to mx plus c, or it is minus times coefficient of x upon coefficient of y. So it comes out to be 2, or you can write it as y is equal to mx plus c. So that is also the way how you can find the slope of this line. Okay, so it turns out to be 2. Now slope of tangent parallel to this line will be also 2. So that means my 2x minus 2 is 2. That means x is equal to 2. And x is 2, y I'll get it as 7. So point of contact is 2, 7. And the equation of tangent is your y minus 7 equal to 2 times x minus 2. That is y minus 2x minus 3 equal to 0. Okay. Using the form y minus y1 equal to m times x minus x1. And now for the second case, this slope, these two lines are perpendicular. So slope of this line is, again you can express it in your y equal to mx plus c form, or otherwise minus a upon b you can compare it with. So I'll get the slope as 3. And the slope of required tangent is perpendicular to this line, so it is minus 1 upon 3. Okay, I can go for this like this slope and this product, this is equal to minus 1, or you can go for this is the slope of required tangent, so this is perpendicular to this line, so it is minus 1 by 3. Okay, so that means 2x minus 2 equal to minus 1 by 3. So you can go like this way also, or you can write that the slope of this means 2x minus 2, okay, this into the slope of this line 3. The both product is equal to minus 1. Okay, and in the next step you can take this 3 to the denominator and 1 in the same thing we can get. So x is 5 by 6 and y you can calculate by putting the value of y in the equation. Okay, so here I'll get it as 217 by 36. So my point of contact is 5 by 6 and 217 by 36. Okay, and the equation of required tangent will be at this point of contact is y minus my y1 this and equal to m times x minus x1. So on solving, I'll get it as 12x plus 36y plus is equal to 227. Number 16 is show that tangent to the curve y equal to 7x cube plus 11 at the points where x equal to 2 and x minus 2 are parallel. Okay, you have to show that tangent to this curve at these 2 points are parallel. So that means definitely their slopes are equal. So this is the equation of tangent. This is the slope of tangent is the value of derivative at xy. Now put when x equal to 2, slope of tangent at x equal to 2. It is 84. 21 into 2 square, that is 4, that is 84. And for the second one minus 2, it is again 84, as square makes it positive. So since the slope of two tangents are equal, that means the tangents at x equal to 2 and minus 2 are parallel. Number 17 is find the points on the curve y equal to x cube at which the slope of the tangent is equal to the y coordinate of the point. So it's a very good question. Now equation of given curve is this. Slope of tangent will be the value of derivative. Okay. Now slope of the tangent is equal to the y coordinate. So what does it mean? That is 3x square equal to, say the point is your, my point is like this. This is the y coordinate. Okay, y coordinate. So that means, shall I say that 3x square equal to x cube? Okay, is equal to y. That means it is equal to x cube. So from here, I'll get this equation, and taking x square common, I'll get two factors x0 and x3. Okay, so when x is 0, y is 0, point 0, 0, and when x is 3, my y is 27, that is point is 327. Okay, now next question is, find for the curve y equal to 4x cube minus 2x raised to power 5. Okay, find all the points at which the tangent passes through origin. So this is also very good question. So this is my curve. Required point is pxy at which the tangent is passing through origin, so that the passing point is 0, 0. So I'll differentiate this to both sides. Dy by dx is my 12x square minus 10x raised to power 4. Now slope of tangent will be the value of derivative. Okay, that is 12x square minus 10x raised to power 4. And the slope of line joining, see, these 2 points will be your y minus 0 upon x minus 0. Okay, so that means y upon x is equal to 12x square minus 10x4, or I can write it as by multiplying it y is equal to this. Now putting the value of this y in the equation, I will get it as my x is either 0 or x is plus minus 1. So when x is 0, the y value is 0. When x is 1, y is 2, and x is minus 1, y is minus 2. So I'll get the point as 0, 0, 1, 2, and minus 1, minus 2. Okay, so number 19 is, find the points on the curve, your x square plus y square minus 2x minus 3 equal to 0 at which the tangents are parallel to x-axis. So tangent parallel to x-axis, that means slope is 0. Slope of tangent is 0. So this is again my curve, the derivative. This is 1 minus x upon y. Now tangent is parallel to x-axis, that means slope of tangent is 0. Okay, so 1 minus x upon y equal to 0 gives me x1. So I'll put it back here. So y square I'll get 4. That is y is plus minus 2. So the points are 1, 2 and 1 minus 2. 20 is, find the equation of normal at the point for the curve ay square equal to x cube. Now the equation of curve is ay square equal to x cube. Differentiating both sides. Okay, I'll get it as dy by dx turns out to be 3x square upon 2ay. Okay, this is the slope of tangent. Now at this point, am square upon and am cube. So put x as am square. So it becomes 3 am square whole square upon 2a into am cube. So it becomes 3m by 2. And the slope of normal will be the negative reciprocal. So it is minus 2 by 3m. Okay. So the equation of normal will be y minus y1 equal to m times, this m I will use, x minus x1. And on solving, it is 2x plus 3my minus am square times 2 plus 3m square equal to 0. Number 21 is, find the equation of normal to the curve. This is the curve which are parallel to the line. So again the connection is that the slopes are equal. So I'll start with, this is the equation of curve. Differentiating, I'll get dy by dx equal to 3x square plus 2. So this is the slope of tangent to the curve at xy. And slope of normal will be minus 1 upon this negative reciprocal. And the slope of given line is, on expressing it as y equal to mx plus c, I'll get it as minus 1 by 14. Okay. Now since the normal is parallel to this line, so that means this slope is equal to minus 1 by 14. So here I get it. And on solving, I get x as plus minus 2. So when x is 2, y is 18. And when x is minus 2, y is minus 6. So the coordinates are 2, 18 and minus 2, minus 6. Okay. And the equation of normal at 2, 18 will be y minus y1 equal to m. I'll use from here x minus x1. So it is x plus 14y minus 254 equal to 0. And for the second point, I'll get it as y plus 6 equal to m times x plus 2. So it is x plus 14y plus 86 equal to 0. Next is, find the equation of tangent and normal to the parabola y square is equal to 4ax at the point 80 square and 280. So tangent and normal both I need to find. So this is my curve. The derivative is dy by dx equal to 2a upon y. Slope of tangent at xy is 2a upon y. Okay. Now slope of tangent at the point 80 square 280 is your 2a upon 280. Put the values. So it is like 2a here, nothing you need to put, but y is 280, so it is 1 by t. Now slope of normal will be the negative reciprocal, that is minus t. So the equation of tangent is at this point is y minus 280 equal to this slope of tangent, that is 1 by t x minus 80 square. So it gives me ty equal to x plus 80 square. And for the normal, for the same point, I'll use the slope as minus t. So using this, I'll get it as tx plus y equal to 280 plus 80 cube. Number 23 is prove that curves x equal to y square and this curve xy equal to k cut at right angles if 8k square equal to 1. So cut at right angles is that means two curves they cut at right angles, means if I draw the tangents are also perpendicular. Okay, so perpendicular means the product of their slopes is minus 1. So start with x equal to this y square, xy equal to k. So to find the point of intersection, what we do, we need to solve them. Means I can put the value of x from one equation to other, or likewise I want to solve. So x equal to y square, I'll put it here. So I'll get y cube equal to k, that is y is cube root of k. And similarly, the value of y I can get from here, that when y will I put it here in x, so I'll get x as k raised to power 2 by 3. So the point comes as k raised to power 2 by 3 and k raised to power 1 by 3, which is my xy. So as you can see, the answer is just in the form of, now differentiating my 1, I'll get dy by dx equal to 1 upon 2y, which is my slope m1, and the second one equation I'll differentiate, so dy by dx is minus 5 upon x, which is m2. Okay, now since both the curves cut at right angles, that means m1 into m2 is minus 1, product of slopes is minus 1, so it becomes 1 upon 2y minus 5 upon x equal to minus 1. So that is 1 upon 2x equal to 1. 2x is equal to 1. Okay, but from equation number 3, what I need to do is I'll put the value of x, that is k raised to power 2 by 3. So this 2k raised to power 2 by 3 equal to 1. Okay, so what I need to do is I have to remove this, okay, this power 3 from the bottom. So what I'll do cubing. So cubing 2 to the 4 to the 8, it is 8, and k square is left, and the cube of 1 is 1 itself. Number 24 is find the equation of tangent and normal to the hyperbola at x naught y naught. Okay, so equation of hyperbola is this. So the derivative is dy by dx equal to b square x upon a square y. Okay, so putting x as x naught and y as y naught, slope of tangent, as the point is given, so I have to use it. At x naught y naught is the value of derivative at this point, so that is b square x naught upon e square y naught. And equation of tangent at this point is y minus y naught is equal to this my slope times x minus x naught. Okay, so now cross multiply y naught. Okay, y naught minus y naught square equal to my b square upon a square and x naught minus x square, x naught square. Okay, so on what I will do is from here I'll combine the likewise terms, like I'll bring x naught and y naught terms like this. So I'll bring this, take this to other side. Okay, so x naught upon a square minus y naught upon b square. Okay, this is equal to my, bring this to this side, so it becomes x naught square upon a square minus y naught square upon b square. But you can see from equation number 1, okay, this is equal to 1, right? Because this point x naught y naught is also satisfying this equation. That means x naught square upon a square minus y naught square upon b square is 1. So this side becomes 1. So the equation becomes x naught upon a square minus y naught upon b square equal to 1. Now slope of tangent at x naught y naught is b square x naught upon a square y naught, and the normal will be negative of reciprocal of this, and equation of normal will be y minus y naught equal to minus this slope times x minus x naught. And on solving, what I will get an equation like this. Okay, so bringing it to some standard form, I'll divide throughout by a square b square x naught y naught. So I'll get the equation in the form of x minus x naught upon b square x naught plus y minus y naught upon a square y naught equal to 0. Number 25 is find the equation of tangent to the curve. Okay, this is my curve and parallel to the line. So you know the connection between parallel lines, that their slopes are equal. So what is the equation of curve? This is the equation of curve. And the derivative of root x is 1 upon my 2 root x. Okay, and the ddx of this 3x minus 2, that is 3. So this is my derivative, which is the slope of tangent at the point xy. Okay, on slope of line is, you can just express it as in the form of y equal to mx plus c, or you can get minus c upon v, which is 2. And required tangent is the parallel to the given line. So that means slope of this slope is equal to this one, 2. So cross multiplying, I'll get my x as 41 upon 48. So x is 41 upon 48 and y, I can get by reputting the value here. So y is my 3 by 4. So my point is 41 by 48 and 3 by 4. Okay. So what is the equation of required tangent? Required tangent is y minus y1 equal to m times x minus x1. So this is y minus 3 by 4 equal to 2x minus 41 by 24. And on solving, I'll get my equation as minus 48x plus 24y equal to minus 23, or 48x minus 24y equal to 23, adjusting the signs. Number 26 is the slope of normal to the curve at x equal to 0. So you have to check out of the correct option. So for slope of normal, you know, I'll first find the derivative, which is 4x plus 3 cos x. So this is the slope of tangent at point xy. Okay. Now putting x as 0, right? What will I get the slope of tangent as? It is just my 4 into 0 plus 3 cos 0, that is 1. So it is just 3. And this is the slope of tangent. So what is the slope of normal? Negative reciprocal. So it is minus 1 upon 3. So that means my D is the correct option. Number 27 is the line y equal to x plus 1 is tangent to the curve y square equal to 4x at the point. You have to check that when this line is tangent to the curve. Okay. So again, since the curve is this, and differentiating dy by dx is 2 by y, which is my slope of tangent to the curve at point xy. Again, the slope of line is y equal to mx plus c. So I think slope of line is very clear that it is 1. Okay. And this means 2 by y, as this is the same tangent to this curve. So slopes are equal, 2 by y equal to 1. So my y is 2 and x I can get by reputting the value here. So x might turns out to be 1. So here the point of contact is 1, 2. That means option number A is my correct answer. Okay. So this is how we will solve the questions based upon concept of tangents and normal. So I hope this topic is clear to you. This is a very important topic, as from this topic you can get a 6 marks question also in the final examination. Okay, the concept of tangents and normals is very important, and it's also very simple, because you know what is the connection between the slopes of parallel and perpendicular lines, and how to frame the equations of tangents and normals. Okay, and all these concepts learned, please do revise them well, and the concepts are very easy, and definitely your skills of calculating the derivative of the function is definitely going to be tested in this topic. Okay, so I hope everything is clear. Thank you very much.